Hello everyone, welcome back to my channel. In my video today, I am going to talk about calculus again, but this time it's not differential calculus. I'm going to move on to integral calculus. So anti-differentiation or integration is the topic for today's lesson, and I'm going to focus on integral of x to the power of n type. So we're going to look at algebraic functions in today's lesson. So anti-differentiation, it's nothing but the inverse of differentiation. So if you were to derive any function with respect to x, so that's our function, you would get f dash of x. But what happened if you had to get from that function to this function? So I'm going to use a symbol that looks like that. It looks like an S representing sum, Raymond sums. So later on we're going to learn about trapezoidal rule, so you'll understand that better, the concept of sums. So that symbol, the integral symbol of f dash x, the derivative with respect to dx, gives us the original function, which is the antiderivative. So that plus c, or you can consider just any function, to derive any function. You're going to get uppercase f, which is the antiderivative, plus c. So what is this c? I'm going to discuss about what the c means. So the formula used looks like that: x to the power n plus 1. So given any algebraic function x to the power n, so that could be, the n could be 7, it could be -3, anything, any number. So what we're going to do is, with that formula, x to the power n plus 1 divided by n plus 1. So that's the formula, plus c, the constant of integration. So what is this constant of integration? So let's say you have to find the derivative of x to the power 5 plus 2. So what's the derivative of that? It is 5 times x to the power 4, which is the derivative of x to the power 5. And what's the derivative of 2? It's nothing but 0. So that's a constant there. Let's consider another case. Let's have an x to the power 5. This time let me have a -8 as the constant. Again, the derivative is 5 x to the power 4 plus 0. How about x to the power 5 plus 70? Yet again, you get 5x to the power 4 plus 0. So it does not matter what constant function you have, whether it's a +2, -8, or 70, the derivative of any constant is 0. Now, if we were to go in the opposite direction, so starting at the derivative, and if you had to find the integral of this, by applying our rule, you should get something like x to the power 4 plus 1 over 4 plus 1. So remember, the n value is 4. That's why it's 4 plus 1 over 4 plus 1. Plus the integral of those constants. Now that constant could have been a 2, a -8, a 70. So it's a general, a potential constant. So that's why we have a c there. So that equals 5 times x to the power 5 over 5 plus c, and then simplified, it gives us x to the power 5 plus c. So can you see the link between the antiderivative and these functions? So that c there could represent the 2. It could also have been a -8 or the +70. So that c represents any potential constant. We'll discuss some basic properties of integrals. The first one is consider any constant k okay, times a function. So you could have, let's say, an integral of 7 times x cubed. To find the derivative, you can place the 7 outside that integration symbol and integrate x cubed using that rule. Similarly, you have two other properties, one where you have been given a sum of two functions, let's say x cubed plus x. So you can, based on this property number 2, you can split these functions up. So that's x cubed dx as one function and x dx as a second function, and individually you can integrate these functions. A very similar property deals with subtraction, the difference between two given functions. So instead of x cubed plus x, if you had x cubed minus x, you can integrate them separately. So that's what these properties are. In our examples, we are going to look at some of these properties. So in our first example, very basic example, we need to integrate 2 times x to the power 6 dx. So 2 times x to the power 6 dx. Now, based on our first property, the 2, which is the constant, can be placed outside. And then, understanding that the n here is 6, so we apply that formula, x to the power n plus 1 over n plus 1. So that gives us 2 times x to the power 6 plus 1 over 6 plus 1 plus the constant of integration. Now I simplify it. 2 times x to the power 7 over 7 plus c. So that's the final answer. Some people might want to make it look neater. So 2, 7, x to the power 7 plus c. The next example, we've been given a combination of functions, sum and difference. So I might write them separately. Second function and the third function. So this is 5 times the n value is 2, so x to the power 2 plus 1 over 2 plus 1 plus 7 times x to the power of, that there's 1 there, so n is 1, so 1 plus 1 over 1 plus 1 minus 8 times, now this is interesting, you don't see any variable x, but we assume that there we have some x to the power 0, because x to the power 0 or anything raised to the power 0 is 1. So if we have an x to the power 0, therefore our n value is 0. So we could apply the rule as x to the power 0 plus 1 over 0 plus 1. And now we include the constant of integration. We don't need to include the c after every term because that c is common. Now, in the next step, I'm going to simplify it. So that's 2 plus 1, 3. I'll write it as 5 thirds x cubed plus 7 over 2 x squared minus, that when simplified becomes 8x plus c. So that was an example where we applied properties 2 and 3 together. And then here I am going to talk about the integration of a constant term. So imagine there's a 1 times dx. Okay, so 1 is a constant. Or I can rewrite the 1 as x to the power 0 dx. When n is 0 and we apply the rule as I have shown in the previous example, we get x plus c. So integral of just dx is x plus c. This is important to remember. In our next example, I am going to apply one of the properties. So this time you've been given a combination of functions. So I'm going to rewrite this in this form. So I've kept the constants outside. And then I'm going to apply the formula x to the power n plus 1 over n plus 1. So that's going to give me x to the power 4 over 4 plus 2 times x cubed over 3 minus 3 times x squared over 2 plus 10 times x, because that equals x to the power 0 plus the constant of integration. Now you can leave the answer in this form, or if you want, you can make it look neater by combining all the constants or the numbers. It looks better this way. Okay, and our last example. So this looks tricky, but it is not. It's really easy. So I can rewrite the function as 1 over 4, and then I'm going to bring the x to the power 5 to the numerator, and so therefore x has a negative sign. So now I'm going to find the integral of this expression, and so if I take the 1/4 outside and rewrite it in this form, so here n is -5. So if you apply the rule, 1 over 4 times x to the power -5 plus 1 over -5 plus 1 plus c. So that equals 1 over 4 x to the power -4 over -4 plus c. And then we can simplify it. That becomes -1 over 16 times x to the power -4 plus c. You can leave the answer in this form, but if you do not like the negative power, you can rewrite that as x to the power 4 plus c. So that x to the power 4 should be the denominator. That's it, people. I hope you liked my video on anti-differentiation, and I hope you've learned how to integrate algebraic functions. Thank you so much. Please like this video and subscribe to my channel. Hope to see you in my next video. Thank you very much. Ta-da!